We're going to work through 3 short examples dealing with electron configurations. If you need more help understanding how to read the periodic table and the different blocks, check out the other video I posted today. Let's get started. What is the electron configuration of zinc? To determine an electron configuration, you start up at hydrogen and you work your way across the periods of the periodic table until you get to the element in question, filling in the orbitals as you go. Zinc is here. So we start at hydrogen, we fill the 1s orbital, so it's got 1s2 because there's 2 electrons in that full orbital. Then we've got the 2s orbital, 2s2, the 2p orbital, 2p2 or 2p6, 3s orbital, 3s2, then the 3p orbital, 3p6, 4s orbital, 4s2, and then we count our way all the way across the 3d orbital to zinc. So that's going to be 3d10. Let's try something a little more complex. What is the electron configuration for bismuth? Now, bismuth is way down at the bottom of the periodic table. It's also my favorite element. But if we're going to write out the whole electron configuration, that's going to take a long time. Let's use condensed electron configuration. To do that, we're going to start from bismuth and then work our way backwards. Backwards, 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 and find the nearest noble gas, in this case, xenon, which we will write first in brackets. And then we'll work our way forwards again, listing the electrons as we go. So starting from xenon, first we come down to the 6s orbital, that's 6s2. And now, in between barium and lanthanum, we need to hop down to the lanthanides. This is the 4f orbital. So 4f, and it's going to be 4f14 because it's full. And after that, we can come back up from lutetium to lanthanum and go across the 5d orbital. And it's going to be 5d10. And finally, we're in the 6p orbital, and we've got 1, 2, 3 electrons in that 6p orbital. So 6p3. Now last, what is the electron configuration of a bromide anion, and what is it isoelectronic to? To figure out an ion, the first thing you need to do is figure out the parent atom's electron configuration. So we've got bromine here. Let's go ahead and use the condensed format. Start from argon. Travel across, so we've got 4s2. Then we travel across the 3d orbital, 3d10. And then we get 1, 2, 3, 4, 5 electrons in to the 4p orbital. So 4p5. Now that is bromine. If we want bromide, we're going to add 1 electron because it has a -1 charge. And these electrons will always get added to or pulled from the highest energy orbital. So this last one you list in the electron configuration. That's where it's always going to come from unless it's one of the transition metal exceptions. There will be a video on that later this week. But now let's add this electron. We'll write out our condensed configuration, 4s2, 3d10, and then it's 4p6 because we added an electron. This is bromide. Now what is this isoelectronic to? Isoelectronic means that they have the same electron configuration. So what we can do is just walk forward from bromine. So bromine, we added an electron, so it should look like krypton. It is isoelectronic to krypton. I hope that cleared up some things. I will see you guys on Wednesday.